Hello, Pre-Calc Honors kids. This is Miss LaFour, and today we're looking at 10-4 inverse trig functions. So the very first part of here, notice it says recall. How do we solve the following equation? So if you remember this first bit, you would subtract 5 from both sides, right? You're doing the inverse operation here, and we get 8. Here we would do the inverse of multiply by 7, so we would divide by 7 and get an answer. If we have something that's exponential, to undo exponential, that's when we take the log of both sides, remember? That would be our first step. And then, of course, we would keep going from there. Here we can use the properties of logs, bring down that x, and then to get x by itself, divide by log of 2. So you get log of 24 divided by log of 2. If you have just sine of theta is 1, then inverse here would be theta is equal to the inverse sine of 1. And then, of course, you'd have to look at your unit circle and all that, which I'm going to teach you how to do that today. But theta here would be pi over 2. That's the angle measure that's going to give us a sine value of 1. So whenever you see arc sine, that's the same thing as sine inverse. Sometimes you see it as with a -1. That's traditionally how I write it. So let's say this is some number c, okay, and then we have theta. If you see it like this with the word arc sine, it's the same thing, okay? Sometimes you'll see it arc sine, sometimes you'll see it with that -1 exponent, but they mean the same thing. So when we look at the graph of sine, if you recall what it looks like, and notice we've got it there, if you take the inverse of that, then your x's and y's flip around. So here, when I have the point 0, 0, guess what? That's still 0, 0. But then when I flip the other ones, like here would be pi and 0. So here would be 0 pi. Here would be pi over 2 and 1, so 1 and pi over 2. Going backwards, well, actually, it keeps up this pattern. Going backwards, we'd have -1, negative pi over 2, so -1, -1, negative pi over 2, there we go. And then back to 0 again here. So notice that it's the same curves, it's just kind of flipped around like that. Now, this does go on and on and on, okay? It keeps on following the same pattern, but the issue becomes that it's no longer a function because it doesn't pass the vertical line test. So what we do on these, if we have to restrict the domain so it can be a function. So when we're looking at inverse, we're really looking at, let's see, for this one, I'm going to look at from negative pi over 2 to pi over 2, okay? So really only that portion. So the rest kind of disappears. So I'm only looking at that because every value is represented between the -1 and 1. And it's still a function if I only look at that piece. So we need to understand that the inverse sine is only from negative pi over 2 to pi over 2. So when I'm looking at values of theta for the inverse sine, I'm only going to use quadrants 1 and 4, okay? I'm not using the other because it wouldn't be a function at that point. So you need to just remember that piece. So notice here we have domain. Domain is the, -1 to 1. And then the range is negative pi over 2 to pi over 2. Okay, so it's the flip of domain and range, basically. Well, we have to restrict the domain on it, so it's a little bit different. But anyway, so that's our domain and range. Now, when we go to cosine, it's very similar, where, if you have these points, and again, we have to restrict our domain, this one's getting restricted, let's see, this would be pi over 2 and 1, so 1 pi over 2, because it's flipping it around. This is 0, 1. So 0, 1. 0. Yeah, it is 0, 1. 0, 1, 1, 0. Oh, I got that one in the wrong spot. I'll fix it. There we go. 0, 1. There we go. And then this would be pi over 2 and 0. I got it backwards. Here we go. And then this one's here. Now, granted, this is just a piece, right? This curved this way and it curves that way, because it would have continued going like this. Okay, this would have been another 0. Then it would have been back to the -1. And it keeps going like that. But we're going to restrict our domain. Oops, there we go. We're going to restrict our domain to only look at this portion, okay? To only be that part for your your cosine graph. So that means when we're looking at these, okay, cosine, we're only looking at quadrants 1 and 2. So our domain here is from, let's see, -1 to 1. And this is from 0 to pi. Then on the next page, let's see, we got, I think we got tangent over there. Yes, we do. All right, so on tangent, notice here the reciprocal is going to be, let's see, if we take one of these and flip it around, I'm still going to have 0, 0. We're flipping around the x's and y's, so I'm still going to go through these points. But this time it's kind of going this way. Actually, that point's not the same. Here, let me fix it right quick. That's what I get for trying to go quickly, huh? So I know I've got a dashed line here. There's my asymptote. Here's another asymptote. And it kind of goes like that. There we go. So that's what it is. So we have domain of our tangent. It's all real numbers. Because it goes on, x could be anything. But the range, though, is only between negative pi over 2 and pi over 2, because that's where our asymptotes are. So basically, these are horizontal asymptotes. So notice this is a parentheses, not a bracket, because it does not include it. Now, it has the same area as the inverse sine, except it's brackets. It's not or equal to. So that's the only thing that's different for that one. All right, so when we look at an angle versus two sides of a triangle, so remember sine of an angle, and this represents an angle measure, theta represents an angle measure, then it is opposite over hypotenuse. Cosine of our angle, and again, that's an angle right there, an angle measurement, would be the reciprocal of that, which is 1 over sine, which I could say is hypotenuse over opposite, though I don't really memorize it or anything like that. So if I do inverse sine, I'm saying that this is the inverse sine of opposite over hypotenuse here is equal to theta. So my angle is out here. I'm just wanting you to make sure you recognize that. So same thing with the inverse cosecant. This would be hypotenuse over opposite, which would give us inverse sine of opposite over hypotenuse is equal to theta. So this is how we're going to have to put it in our calculator. You're going to need to make sure you know how to do that. So if we have, and this is calculator usage here, the cosecant, inverse cosecant of 2.67. So this means this would be the inverse sine of 1 over 2.67. And if you plug that in, you're going to need to be in degree mode. You'll get a degree of 22 degrees. Notice on this one, we are doing radian mode because this one is not an inverse. Okay, inverse, we're going to use degree mode just to keep it uniform. But radian mode here, because it's not inverse and it's not a degree, so with no degree symbol there. So to put in secant, this would be 1 over cosine of 0.15, and you should get 1.011. Of course, that's in radians. All right, so number 3, find the exact value of the expression without the use of a calculator. All right, so what this means is we have an angle measure that's equal to square root of 3 over 2. So I'm going to draw it out. Okay, just sketch me a little thing here. Oh, I'm waiting for it to pop into place, but that's only on notability, and this is not notability. Okay, so here's my theta. Sine for square root of 3 over 2, that's our y value. So I know that this, let's see, would be an ordered pair of 1/2 square root of 3 over 2, because remember, that's what goes together on my unit circle. So I don't even need to know theta, the angle measure, which I do know from the unit circle, but I don't need to. All I know is the y value is square root of 3 over 2, which means our x is 1/2. So now I have enough to find the tangent of it. So I know tangent of this angle is, let's see, that would be sine over cosine. So square root of 3 over 2 over 1/2, which is just square root of 3. On the next one, number 4, use a reference angle to find the exact value of this. Okay, so here I'm going to just draw an angle. This one's not on our unit circle. Sine is opposite over hypotenuse. So 13 is here. This would be 5. So because this is a Pythagorean triple, I know this is a 12. If not, you can do your Pythagorean theorem and figure it out if you don't know what it is. All right, so this is our angle. So tangent of this angle would then be opposite over adjacent, and we're done. Yay. Okay, let's look at this last one. A photographer wants to photo a hot air balloon launch. Write an equation to model the angle theta of his camera as a function of the height s of the balloon. All right, so here's theta, there's s, and the balloon's going up, obviously. So let's see, that's tangent of theta is equal to, it's s, I'm going to write it capital and cursive, over 500. So I would say theta is the inverse tangent of whatever s is over 500. And then, of course, they're asking us to graph it. And if you graph it, it kind of looks like this, okay, where this is degrees on this side. This is 90 up here. This is going to be S, which is your height down here. And I've got like 1,000 labeled right here. But you don't really have to worry about graphing it. I'm not going to ask you to do that on the test because we're down to 1 day. You don't have to do any graphing on this part. So we're going to look at the homework assignments, and I'm going to put it here. Basically, let's see, no graphing. No graphing for this lesson, okay? And that's the inverse ones, just because we only have 1 day. So the ones you need to do for homework is, let's see, 10 to 17. Do that part. You need to know how to do that. Let's see. Actually, the next section too, this is 18 to 25. You need that. Reference angle, yes, 26 to 29. Okay. The skills review, I would suggest go ahead and do skills review, but I believe I took the skills review off of the test. Okay, I can double check on when I see you in class, but I think this is not on the test because I shortened it to make sure we have time. And let's see, number 3, so 2 and 3 on the application is what you need to look at. Yeah. So 2 and 3 on the application part. And then that's all you got to worry about for 10-4. All right. Have a good day.